Consider these. A hard disk drive is a collection of plates called platters. The surface of each platter is divided into circular tracks. Furthermore, each track is divided into smaller pieces called sectors. A group of tracks that are positioned on top of each other form a cylinder. There is a head connected to an arm for each surface, which handles all I/O operations. In a disk system, head rotates just above both surfaces of each platter. All heads, being attached to a disk arm, move collectively as a unit. To enable a read and write operation, the platter rotates beneath the stationary head. Data are organized on the platter in tracks, which are in the form of concentric set of rings. Considering that a computer system would normally have several disk requests at any given time, the operating system manages the requests using the different disk scheduling algorithm. This is the graph for the given problem in the FCFS. As you notice, the Q that is given is written in order and are lined graphically, downwards, 95, 180, and so on. Having the previous position of read-write head at 64 and initially at 50. Broken line represents as no servicing of request and straight line as servicing of request. Meaning to say, 64 and 50 are not included in the given Q. The number of tracks are 200. We always start at 0 so it ends at 199. To compute for the head movement, we will subtract innermost request from outermost request. To get its total, or the total head movement, we will add all of the head movements within the queue. And for the seek time, we will multiply the total head movement to seek rate. Assuming we have a seek rate of 5 milliseconds, we will get 3220 milliseconds of seek time. FCFS algorithm is like having a student assessment. The first one in the queue will be processed first. Same goes for the others, the first student who come and request will be entertained first. In this case, request is serviced according to next shortest distance. Starting at 50, the next shortest distance would be 62 instead of 34 since it is only 12 tracks away from 62 and 16 tracks away from 34. The process would continue until all the process are taken care of. Computing for the total head movement for the following algorithm is the same as FCFS algorithm. In here, we try to simplify computation by subtracting innermost track to outermost track instead of subtracting it one by one. The formula for SSTF seek time is the same in FCFS. It does also apply for all algorithms. Usually in a flag ceremony, the queue of students are arranged by height. Like the SSTF algorithm, they are arranged by size of their height, having the shortest first up to the tallest one. We can assume that the length of track is like the height of students. The shortest distance will go first.
Created using Powtoon.